Good morning, grade sixes, and welcome to this beautiful Wednesday morning that we have. This is WorksheetCloud, and my name is Mrs. Hall. Today's lesson is lesson number 3 in my series on electricity, and today we are going to be looking at electrical circuits. The objectives of today's lesson are as follows. We are going to look at electrical circuits, circuit diagrams, circuit symbols, parallel and series circuits, and we got lots of practical examples for you to work through today. So I hope you enjoy this lesson and you leave it thinking, wow, I learned something new today. Right, circuit symbols, what are they? Electrical circuits are often represented by circuit diagrams, and rather than spending lots of time creating very artistic drawings of circuits, we use standard symbols that are much simpler and easier to draw and much easier to interpret, and they are globally recognized. That means if someone gets given a circuit diagram anywhere in the world, they know exactly what they need to put into that circuit. So here we have a few basic symbols. These symbols represent components such as a bulb over here, an ammeter and a voltmeter, and they are used in circuit diagrams. Right, just like everyday symbols that you know, okay, we know them well. That's exactly what electrical circuits are, the symbols are like. You get to know them really well. The more you practice, the more circuit diagrams you draw, the more you will recognize them. Just like these symbols over here. You know what they mean. You see them every day. So you know Apple, you know Coca-Cola, you know Twitter, you know McD's, and you know what the fair trade symbol means. So we spoke about an ammeter and a voltmeter. So I want to just quickly tell you the difference between the two of them. So an ammeter is a measuring instrument that you can see over here that is used to measure the current in a circuit, and electrical currents are measured in amperes. I did mention that to you in my last lesson. A voltmeter is an instrument used for measuring electrical potential difference between 2 points in an electric circuit, and you get to learn about that in the higher grades. So our basic circuit symbols that we will learn about at a grade 6 level is a battery. I did that in quite a bit of detail yesterday. Remember, a single cell, and then when you have 2 or more cells joined together, you have your battery. Your electrical wire is just a simple straight line. Your bulb. There are other symbols for bulbs that are globally recognized, and you will see them in the circuit diagrams as we go through them today. A buzzer, a motor, a switch, that will be an on switch, an off switch, and that there is switched on because it's closed. Okay. So let's take a look at the scientific circuit symbols quiz. So we're going to match the parts of a circuit with their scientific symbols. Sometimes there will be more than one symbol for a circuit part. Okay, so here we have all of our different circuit components and which symbol belongs to which components. So over here we have our light bulb. And as I said earlier, that could be the symbol for your light bulb, and here's a new one as well that is also globally recognized. Your cell, your single cell over there with your positive and negative points, that would be your conducting wire, that is your crocodile clip to connect to your different components. Here we have our switches, okay. We get different kinds of switches. Here we go on off, and here we just push it sideways on off as well. Here we have our buzzer. It's a sound device, okay, and that is how you would illustrate it on a circuit diagram. And over here, exactly what I said, 2 cells connected together form our battery. Right, so when it comes to drawing circuit diagrams, there are certain rules that we must follow every time. So we always draw circuit diagrams using straight lines, okay? So you need a ruler. You use a pencil and a ruler to draw these lines, okay? Not freehand. I love it when you're in class and you just scribble that line with your free hand. It will not be scientifically correct if you do not use a ruler. Okay, so how would you begin to draw this circuit over here? We have our conducting wires, we have our cell, and we have our light bulb. Okay, following these basic rules, this is what your circuit diagram should look like. Straight lines, here is my cell, straight lines, and here is my bulb. Very, very simple. I want you to practice drawing some general circuits on your own at home. So go look at your natural science textbooks for grade 6, and there are lots of exercises that enable you to draw your own circuit diagrams. So making a light bulb glow. Generally, an electric circuit will transfer electric energy into some other form. And we spoke about those forms yesterday. It could be light energy in the form of a bulb, it could be heat energy, motion energy, etc. If we connected a light bulb to the battery with wires in between, we have a simple functional circuit. So here I have a schematic. It's a battery over here on the left-hand side connecting to a light bulb over here on the right-hand side. The circuit is completed when the switch at the top closes. Okay, open, closed, open, closed. Okay, quite mesmerizing. With the circuit closed, electrons can flow, pushed from the negative terminal, remember, negative, over here is our electron flow of the battery through the light bulb to the positive terminal on the other side of the circuit. Okay. So here we have a closed circuit. It is a complete circuit. A little bit of revision. We did cover this yesterday. And here we have an open circuit. It's an incomplete circuit, right? So over here, what do you think will happen to this bulb over here? And what do you think will happen to this bulb over here? This one will glow, this one will not. Very simple. Now you know how to draw a circuit. Let's take a look at some diagrams and see if we can find the fault. Okay, so let's start with number 1 over here. The first question is, will the bulb light up, yes or no? Okay, so we take a look. There's our switch. Our bulb over here, there's an open gap here, and here is our cell or our battery. Will this one glow? No, okay, because there's a gap, it's broken. Okay, so the current cannot flow continuously. Over here, let's take a look at this diagram. Okay, the switch is open, not closed, but there's our light bulb, there's our battery. If we close the switch, yes, it will glow. When it's open, no, it will not. Here we have another diagram. It just has a light bulb, but there's no energy source. Okay, there's no battery. So no, it won't glow. And over here, we have a battery, but we don't have a device. We don't have an output. Or we can also call it a load. Okay, we don't have one, so no, that circuit will not work either. Okay, here we have a simple electrical circuit like you would have set up in class. Those are the switches we use in class. We would have used our battery and we would have connected our globe. We would have switched our switch on and our bulb or our globe would glow. Okay, take it off and our globe switches off. Right. Very simple, very easy. And if I had to draw that, grade 6s, here we go, my conducting wire, my battery, my switch is open here, and then there's my globe. Let me close my switch and my light bulb glows. Open my switch and my light bulb switches off. Right, common electric symbols that we will know by the end of this lesson. Obviously, some of them are for a higher level in your grades. So if we don't cover them all today and you are interested in learning about them, feel free to do some research on your own at home. Okay, so I'm just covering the basics of what needs to be covered at a grade 6 level today. So there's our battery, there's 2 batteries connected, and there's 3. That would be a single cell on its own. 2 or more cells connected together make a battery. Right, there's our switch. It is closed, so our switch is on. There is our switch. It is open, so our switch is off. So it's off right now. There is our conducting wire. And here we have something interesting. Here wires are crossing, but they're not connected in the circuit. So it just forms a little jump there to say I'm jumping over it, but they're not connected. Okay, some more. We have an electric motor we're going to learn about today. I've spoken about an ammeter and a voltmeter. We don't really cover this in a lot of detail at a grade 6 level. This is an alternating current voltage source, so that is from our mains electricity. Here is our electric bulb, which we do cover, and resistors and fuses we don't really cover at a grade 6 level, but it's quite interesting and easy to understand what they are, just using different terminology. So please feel free to go and look it up. Right, so let's start with an electrical circuit in series. Okay, so here we have 3 light bulbs connected in a row. We say it is in series. We have our conducting wire, we have our cell, and we have our switch. Our switch is open. Okay, let's close it, and our light bulbs switch on in series. If I open it, my light bulbs switch off. Right, a series circuit is a circuit where there is only one path from the source, okay, from our battery here, through all of the loads and back to the source. So these would be our loads, the 3 light bulbs here, okay. This means that all of the current in the circuit must flow through all of the loads, okay. Right, now let's look at the differences between a series circuit and a parallel circuit. So here we have our series circuit, exactly like I said earlier. Okay, all 3 lights connected in a row. I switch it on and the light bulbs turn on. Okay, now let's go back and switch it off, and then let's switch on our parallel, and all the light bulbs glow. Now, what is the difference between a series circuit and a parallel circuit? Each one of these light bulbs is connected to this source over here. So if this light bulb over here had to break, okay, the following 2 over here would continue to glow because they have their own complete circuit still with their source, and the switch is on. Okay, so even if I switch this one and I break it, these continue to glow because they still complete a complete circuit. It is not broken. Okay, so I can switch that one off as well. This one will continue to glow. Okay, so let's get all the light bulbs back. If I, in a series circuit, switch this circuit on, okay, and one of these light bulbs break, okay, none of them will work, and that is because they're all on the same circuit. Okay, so if one of them breaks, all 3 of them switch off. Very interesting. So let's take a look in a table form. So in a series, if one globe burns out or is removed, all the globes will stop working, exactly like I showed you earlier. Whereas in parallel, if one globe burns out or is removed, all other globes will continue to work. The voltage in series is shared between each globe, resulting in reduced brightness. So they share the voltage, okay? So they won't glow brightly. They're sharing the energy. whereas in parallel, each globe receives the full voltage of the source, resulting in all globes burning at the same brightness, regardless of the number of globes. Serial circuits are cheap and easy to construct. You saw how easy it was, whereas parallel circuits require much more effort to construct. So let's predict what will happen when the switch is on. Okay, so take a good look at this circuit diagram over here. Right, let me switch it on. Nothing happens. Okay, take the switch off. Nothing happens. Okay, let's take a look and decide, and I'm going to show you another one right now. This is called a short circuit. Okay, a short circuit. So let's take a look at what will happen here. So here, okay, is another circuit. The switch is closed. The light bulb is glowing. Okay, but now I switch it off and I don't allow I break the pathway, but the light bulb keeps glowing. Okay, I switch it back on. The light bulb glows. I switch it off. It still glows. Okay, what is happening here? This is also a short circuit, but instead the light stays on. And why is this happening, grade 6s? Because there is no load in a short circuit. For many reasons, the wires in a circuit can find a shortcut bypassing the load. Okay, so that would be the load, the light bulb, and any other component in the circuit. This causes the same voltage from cell to flow to the other end of the cell. Okay, so here you can see it happening over here. All right. When this happens, the high voltage causes the wires to heat up and they actually can catch fire. So here's the action, the arrow showing the actual direction of the current flow, and notice how the current makes a short bypass shortcut bypassing the other components of the circuit. Okay, and that is a short circuit. Can you think of reasons why a short circuit may occur? Wires may lose their insulation and touch each other in the circuit. Okay, there could be a fault or improper wiring in a device. Intentionally connecting both ends of a cell or a battery with wires. This causes a massive drain of electricity and the battery loses its power in a very short time. A short circuit can cause heating, melting of wires, harmful smoke and smell, and blinding light, like what you see when you're welding. Okay, and this is what it looks like. Okay, not safe to have a short circuit, grade 6s. That is how electrical fires start in your homes. Right, where would you find this circuit over here? Okay, here, remember, this is coming from our mains electricity. Okay, and if I switch them on and off, look at that. I can switch that one on and off on its own. I can switch this one on and off on its own, and I can switch that one on and off on its own. Where do you think you would find this kind of circuit? This is a very common household circuit. Lighting in a house consists of a parallel circuit like this, with individual switches for each light. And that's why sometimes you walk into your specific room in a house and there's a number of lights. Each one of them turns on a specific circuit to turn on a specific light. Right. Where would you find this circuit? Okay, so now this circuit over here, also from mains electricity, it is closed. Okay, and I can switch these lights on and off. Look how easy that is. But now I open this circuit over here. So I open the switch, I break the pathway of the current, and now what's happening? I can't turn these lights on and off. Close this switch, and then I can turn these lights on and off. What do you think this is called? This is a safety circuit. Individual globes or machines can switch on and off by their own switches, but a safety switch can shut off all the devices at once, and that would be our safety switch. Oh, and then, my favorite time of the year, Christmas tree lights. Are these Christmas tree lights in series or parallel circuits? And what works best, grade 6s? Right, this is a series circuit, as you can see. Okay, look very closely. This is a parallel circuit over there. Okay, now if I have my Christmas tree lights in series and one light breaks, just one light, and this is so annoying, it always happens. If one globe burns out, all the lights will go out and the circuit is no longer closed. And that's pretty annoying when you love those Christmas tree lights flashing. Okay, but let's take a look in parallel now, and this is the benefit of parallel circuits. If one globe burns out, all the other lights will still remain on, and the circuit is still closed in parallel because they each have their own specific circuit to the power source. So amazing. Okay, go out of here. So grade 6s, I really and truly hope that you loved that lesson today as much as I loved giving it to you, and that you now have a solid, clear understanding of circuit diagrams, circuit symbols, parallel and series circuits, and that you can now go and do your homework. If you feel you need to watch these videos again, please feel free, and remember to start with the lesson 1, followed by 2, followed by lesson number 3. Have a great day, grade 6s, and I shall see you tomorrow morning.